Hello everyone. In this video, we will talk about free radical substitution reaction that happens between alkanes and halogens like chlorine or bromine. Okay? It's a substitution reaction. IGCSE students have already learned this in the 10th grade. We just need to learn the mechanism in this for IB. So before we learn the mechanism and the reaction, first we need to understand the two types of fissions. Fissions here refer to breaking of the bond. So when a bond breaks between two atoms, the two atoms have shared electrons. These are the two electrons shared. So if A and B have a covalent bond, they have shared these two electrons. So the question is, when the bond breaks, what happens to these electrons? There are two possibilities. One is that the electrons are equally distributed between both the atoms. So A gets one, B gets one. Second is that one of them gets both, the other gets none. So assuming that A has lost the electron and B gets both the electrons. In the first case, when the electrons are equally distributed between the two, that's called as homolytic fission. And if one gets both, the other gets none, this is called as heterolytic fission. Next thing you should know is that what are the products. So in case of homolytic fission, you get free radicals or radicals. Free radicals or radicals are the atoms or molecules which have an unpaired electron. Matlab, this is the unpaired electron, this is the unpaired electron. Okay, so a single electron, unpaired. Heterolytic fission में, because A has lost the electron, A has become a cation, and B has gained the electron, so B has become an anion. Okay, so this is about homolytic and heterolytic fission. Now let's proceed to the main topic, which is free radical substitution. Free radical substitution, as the name suggests, it's a substitution by free radical. Now, how the free radical is produced, we have just seen that by homolytic fission. Free radical will substitute halogen. Sorry, free radical, which is a halogen free radical, will substitute hydrogen in alkane. So, in free radical substitution, halogen, generally chlorine or bromine, will substitute hydrogen atoms in alkanes. Okay, this is in short the description of what is going to happen. So halogens will be substituting hydrogens in alkanes. So first we'll see the reaction in general and then we'll see the mechanism. So as per this statement, the reaction is between an alkane. Let's take the simplest alkane, methane, plus let's say chlorine. One very important thing that you should know is that this reaction requires UV light. Okay, without UV light, this reaction will not happen. Okay, so UV light provides activation energy for this reaction. So chlorine may say one chlorine atom will substitute one of the hydrogen atom. So one hydrogen atom will leave from here, which means now I have CH3. In the place of the fourth hydrogen, there is a chlorine coming in. And the hydrogen that is lost will go with the other chlorine to form HCl. Now, this is a chain reaction, and this is not the final product because this still has three more hydrogens to be substituted. One hydrogen out of four is already substituted by chlorine. This has three more hydrogens to be substituted. So in the next step, the CH3Cl, the product here, will go again a round of substitution. So again, out of three hydrogens, one hydrogen will be removed, so CH2. One Cl is already there. One more Cl will come, so CH2Cl2. And again, that hydrogen that is removed will go with the other chlorine to form HCl. This still has two more hydrogens, so this will undergo substitution, CH2Cl2 plus Cl2. This time one more hydrogen will be released, removed, so CH, and one chlorine added, CH, plus HCl, and so on. So this will go on till all the hydrogens are substituted by chlorine. So in each step, one hydrogen is removed and one chlorine is added. So this is what happens in this reaction. This is general reaction. So this reaction will produce halogenoalkanes like chloroalkanes, dichloroalkanes, etc. Now let's see the mechanism. How does this mechanism happen? Now the mechanism of this is described in three stages. Basically, if you see the reaction container in which there are, suppose these are the methane molecules. And these are chlorine molecules. If I keep them together, they will not react until I expose them to UV light. So only when you expose them to UV light, the reaction begins. Until then, they will not react. So why the reactants are waiting for the UV light? As I said, UV light will provide the activation energy. But what exactly UV light does? So that the reaction begins. UV light will carry out the initiation process. The reaction begins. How does the reaction begin? The UV light will do nothing to the methane. If the reaction is between methane and chlorine, UV light will do nothing to the methane. It will attack chlorine. So chlorine molecule, it will break the bond and a homolytic fission will take place and you get two chlorine free radicals. So free radicals are shown by this dot on it. So just to show you, this is chlorine. These are the two electrons shared. When this breaks, each chlorine gets one electron. So that's two chlorine free radicals you have. So that's the initiation process. And this requires UV light, or sometimes in the exam they also write sunlight. Sunlight, UV light. What happens after this? Initiation is done. Second is propagation. So next stages of reaction is propagation. Propagation matlab the reaction that continues to the reaction that continues. Now what happens is this chlorine free radicals, one of the chlorine free radical, if that will attack chlorine, sorry, methane. And the free radicals here, all the free radicals are highly unstable. All free radicals are highly unstable and hence highly reactive because they want to become stable. So because they want to become stable, they need to pair up this electron. The instability is due to this unpaired electron. The instability is due to the unpaired electron. If they pair up that electron, they will become stable. Hence, here the chlorine free radical will attack methane. It will take one of the hydrogen and pair up his electron with that. So you get HCl. Now one of the hydrogen has gone with the chlorine, so this methane has lost one electron. Sorry, lost one hydrogen, so this has become CH3, and there is a free radical on carbon because carbon ka paired electrons with that hydrogen which just removed, which just got removed or left. That has become unpaired now. So now methyl has become free radical. Now this has become free radical. Now because this has become free radical, this is highly reactive and highly unstable. So this will not be the end of the reaction because this guy will try to become stable. So in the next step, this methyl free radical will attack chlorine molecule. It will take one chlorine atom to pair up. So CH3Cl. The other chlorine atom will remain unpaired. So Cl. Okay. So this step has also produced a free radical. So again, this will not be the end of it. It will continue. That's the reason why these reactions are called as propagation. Propagation in continuation, it will proceed and on because it will propagate because the free radicals produced are not stable. So the reaction will proceed further to make them stable. Now, if you take a look at these two steps, like there are many steps, but these two steps may the CH3 will get cancelled, Cl free radical, the free radical is getting cancelled basically. So the overall reaction that I'm getting is CH4 plus Cl2 gives CH3Cl plus HCl. So you can see that one hydrogen is being replaced, the reaction that we previously seen. So to replace one hydrogen, to substitute one hydrogen, it takes two steps, the two steps which are given here. So this is mono-substituted alkene, matlab single substituted, one hydrogen is substituted. Now the second hydrogen will be substituted. This will again, the chlorine free radical here will attack this now. Take one hydrogen, like the previous case, HCl. And now this has lost one hydrogen, so this will become CH2Cl and an unpaired electron. Now this CH2Cl, this will try to become stable, so it will attack chlorine molecule. Take one chlorine to pair up, so CH2Cl2 plus the other chlorine will become free radical. So this way it will propagate, it will go on and on until all the hydrogens are substituted. Now, how does this reaction come to an end? That is called as termination steps. Termination steps may, as the word suggests, the reaction will not propagate. Reaction that is happening will not continue in the next step. So in the termination, any two free radicals when they collide with each other, any two free radicals, let's say methyl and chlorine. So methyl is the free radical which is unstable, it wants to pair up his electron. Chlorine is a free radical which is unstable, it wants to pair up his electron. Both want to pair up, so they will pair up with each other and they will become CH3Cl. You can see that there is no free radical produced here, so this will not propagate, this is termination. Similarly, there are other combinations of free radicals colliding with each other. I can take CH3 and another CH3. That will give you C2H6. I can also take Cl plus Cl, giving you Cl2. So these are the termination steps. Okay. So these are the products which will not react further unless another free radical attacks them. Then they will continue to react. But product by itself will not continue the reaction unless it is attacked by another free radical. Okay, so this is all about the free radical substitution reaction. So these reactions will produce halogenoalkanes. Okay, so it's halogen substituting hydrogen in alkanes, free radical mechanism, and carried out by UV rays, which produces the free radical, and it's like initiating the reaction. Once the free radicals are produced, then they will continue the reaction. Okay, so that's all about the free radical substitution, or we can say substitution reaction in alkanes, or these are also called as photochemical reactions because these reactions will not happen without the UV light. Okay, bye.